Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, we provide workshops and exercises to learn about AWS services. These workshops and exercises are published to our website aws-dojo.com. Today I am going to talk about how you can use Amazon Athena Federated query to use Redshift as a data source and query data from Redshift using Amazon Athena. And there are two reasons why I selected this topic. One is there is not very good documentation available about how you can configure this particular federated query. Even I did a lot of hits and misses in order to find the right solution. And second, some of my audiences did ask about this video, so I said, well, okay, why not make a video about it? So let's get started. So what exactly is Athena Federated query? Actually, traditionally, you can query data from S3 bucket using Amazon Athena. And for that purpose, you will keep your data inside S3 bucket, and then you will catalog that data using glue catalog. And then you can query data inside Amazon Athena like you query any table in a relational database. Now with a federated query feature, Amazon Athena can actually talk to any data source. And that data source could be a log, could be a NoSQL database, could be a relational database, could be a file, it could be anything. And from those places, from those data sources, you can query data using Amazon Athena. And for that purpose, actually Athena uses certain Lambda functions, and these Lambda functions are called connector Lambda functions. And these Lambda functions kind of work as a, you can say, a backend business logic. So when Amazon Athena makes a query or it tries to fetch the table structure, schema information, these requests go through these Lambda functions, and these connector Lambda functions are responsible to talk to the data source in the backend to bring data back to you. Okay, and then in addition to this connector Lambda function, Amazon Athena also uses S3 as a spill bucket. So when the query results come back, they go to the spill bucket, and from the spill bucket, they are presented back using Amazon Athena. So in very simple terms, by using these connector Lambda function, Amazon Athena can talk to any of the data source in the backend and make query to those data sources like it used to make or like it makes to the S3 bucket data. Okay. So out of box, Athena has these Lambda connectors for different type of data sources. So for instance, you have for HBase and EMR or NoSQL database like DynamoDB. It has for your relational databases, Redshift, SQL Server, DocumentDB, ElastiCache. In fact, the list is even bigger than what you see here. Plus, you also have a choice to create your own connector. So if you are using any of these data sources in the backend, then you can simply use one of the existing one of the existing Lambda connectors and simply configure it and make it work for you. But if you are dealing with a connector which is pretty much new, if you're dealing with a data source which is new and there is no connector available, in that case, you do have a choice to create a custom connector as well. In fact, I'm planning to make a separate video about how to create such custom connector in the using Lambda function. But for today, we will be using one of the existing connectors. And for today, the data source is Redshift. And we will see how we can configure connection with the Redshift using these connectors and Amazon Athena federated query feature. Okay. So as I mentioned earlier, that the brain behind making this whole thing happen is this connector. And this connector has to be configured. If you configure this connector right, then your query will work. As simple as that. So let's try to understand, if you're trying to configure this connector for the Redshift, then what it takes. And the first thing, which is very important when you're trying to connect, when trying to configure the Lambda connector for Redshift, is you have to configure this Jdbc connection. And it looks like, the format looks like the following. So you will have Redshift, then Jdbc URL, and then you provide username and password. Now, this is the part where I'm not happy with, because if I have seen documentation, guys, and again, it's not a very great documentation, but it does provide information, certain set of information. And I have seen the examples where in place of providing your username password in a plain text, actually you can provide your username and password. In fact, you can keep your username and password into a secret in the secrets manager, AWS secrets manager, and that secret you can mention over here. Okay, and that makes this whole thing very secure, because then your username and password is not in a connection string in a plain text. It is into a secrets manager, and that secret is mentioned in the URL over here. But that configuration works. When I tried a lot, but that configuration works well for PostgreSQL Server database or MySQL database. But when I tried to use the same thing with Redshift, it does not give any error, but it does not work as well. But the moment I try to use this username and password into my Jdbc connection, like I am showing in the example over here, it works. So I think this is one of the drawbacks at this point of time. Either I'm making a big mistake somewhere, and if someone knows how to fix it, please share with me and everyone. But so far, when I tried it, I found it works only if I provide my username and password into Jdbc connection. Now, in order to populate this value, actually you can see that in your Redshift configuration, you have your Jdbc URL. So this Jdbc URL actually you take from here and replace over here. So in this whole Jdbc connection string, this Jdbc URL gets replaced here, and then you provide your Redshift username and Redshift password. This is the one thing you have to provide into your Lambda function. Then what you have to provide is you need to provide a network connection to the Redshift. Now your backend is the Lambda function. That means your Lambda function has to talk to your Redshift instance. That means your Lambda function has to be associated with a VPC so that it can have an ENI in the VPC to have a network connection to the Redshift. In order to do so, we have to provide two sets of information. One is security group and second is subnet ID. So this is the security group of the Redshift cluster. So if you can have more than one security group in Redshift cluster, and you can use one of those security group which you want to use with the Lambda function over here. And then you also provide your subnet information here. So if you click on this link, it will show you what different subnets, and those subnets also you can mention over here. So you can provide comma separated security groups and comma separated subnet IDs. And by this configuration, actually the Lambda function finds a network path to the Redshift cluster, and using that network path, of course, you can connect to the Redshift cluster and it can query the data schema, whatever you want, through your Athena query editor. Okay, so that's the second configuration you do. Then you do small other configurations. For instance, you provide a spill S3 bucket. As you know, Athena uses an spill bucket for to store the query result and show the results out from there. So you have to provide an S3 bucket. As a spill bucket, you have to provide a Lambda memory, Lambda timeout. Generally, these values are default, but if you're finding that it is timing out, or if memory requirements is more, then of course you go and increase the memory requirements over there. Otherwise, generally these connectors have a default setting for memory and timeout, and you change it only when you want to increase it due to any specific requirements. And one more thing from the Athena point of view, as you know that Athena uses the concept of work group, work group, and these work group have an Athena engine versions, and earlier it was Athena engine version 1.0. Recently, AWS launched Athena engine version 2.0, and so your Athena work group should use Athena engine version 2.0. That's another requirement if you want to use federated query. So what are we going to build today? So we'll have a Redshift cluster, and then we will configure a AWS Lambda connector. And with this AWS Lambda connector, we will make query inside Amazon Athena, and we will use an S3 as a spill bucket over here. So this is what we are going to build today. And I'm going to build this whole scenario end to end, and then of course you can follow me at your own pace, and then you can practice it at your own end. So let's get started. So I go to my AWS console, and you can see here I have got a Redshift cluster configured over here. And if I go to my second tab, you can see in this Redshift cluster, I have got a dev database, and that has got a public schema, and that has got 2 tables, customers and employees, which has got some dummy data. Okay. So now we will start the configuration of the federated query. Or configure data source, Redshift as a data source in Athena, so that you can make federated query. So first thing first, we need to check the work group. So if you click on the work group, I'm using a primary work group, which is already using Athena engine version 2.0. But suppose in your case, it is showing something else. What you have to do is you have to select that work group, click on the view details. Then here you click on the edit work group. And there you will find a choice whether you can select Athena version 1.0 or 2.0. Yeah, you can go and say, okay, I want to manually choose it and select 2.0, and that way you can make sure that your work group is using Athena engine 2.0. Okay, so that's one of the requirements which I have just validated. So let's get started and connect Redshift as a data source. So this is the Redshift cluster which we are going to connect as a data source, and this cluster has got 1 database dev and 2 tables under the public schema. Okay, so let's get started. So I say connect a data source, and here I can select my data source. So in this case, I am selecting say query a data source, and you can see it has got so many data sources in the backend. And if you select some of these choices, then there are pre-built connectors available for that, but you can select data sources beyond these choices as well. In that case, you have to use your own connector, and I promise I'll come back with another video which talks about how to build your own connector. So in this case, we are going to select Amazon Redshift, and we click on next. So it will say, okay, so let's choose a Lambda function. So right now there's no Lambda function. This Lambda function I'm using for something else. So I will configure a new Lambda function using a template for Redshift based connector. So there's a template available for Redshift based connector. I'm going to use that to create a new Lambda function. So let's click on this particular button over here. So it's going to open this Lambda management console where I say there's an Athena Jdbc connector, and then we have to start configuring it. Now, first thing is your application name, and I'm going to call it, for instance, Dojo Athena Jdbc connector. Then secrets name. Now, this is where it gets little not happy to me, is that it does ask for AWS secrets manager secret, assuming that the secret is storing the login name and password for the Redshift cluster, and so that I can use this secrets manager to make connection, but that connection does not work. And that's why in my demo, I'm not showing you to create a secret. To be honest, I can put anything here, still it will work. So I say, don't care, to be very honest, because it's not going to be any use. Now I have to provide an S3 bucket name which will be used as a spill bucket. So I'm going to simply provide this Dojo query demo thing. bucket. Then I have to provide this Redshift connection string. So as I mentioned earlier, that you have to provide first Redshift, starting with Redshift, then you provide this whole JDBC URL, and then you provide login name and password. Okay. So let me do that thing here. So I'm just to save the time, I'm doing the copy paste from another screen. So this is how my connection look like, and let me take you through this connection so you understand what I'm doing. So you start with Redshift. This one you add your Redshift, then and then starts your JDBC URL. So your JDBC URL starts from here and goes all the way till database name. So it goes all the way till database name, and after that we provide query string, and the two query string values are one is username and second is password. And guys, don't get very excited. This cluster I have already removed, so you cannot actually try even if you want. Okay, so and this is the part which I'm not happy, because ideally it should be using a secrets name. So I should be able to provide the secrets name over here, and it should be using that secret name to actually fetch the credential and connect to the Redshift cluster. It works perfectly for MySQL and PostgreSQL. For Redshift, it doesn't work. It does not throw error, but it does not work as well. So I have to use login name password here. Then we move ahead. We provide what is the Lambda function name. I will call it Dojo Redshift connector. Okay. And then I have checking the highest memory, taken the highest timeout. I think it's worth it because you're going to fetch data from Redshift, and your data query can take time actually, guys. So security group IDs. So let's provide security group IDs. So if you go to Redshift cluster properties, here we go. If you go to Redshift cluster, oops, why I'm jumping here to there. If I go to Redshift cluster properties, I can see a security group over here. So what I will do is simply copy this security group from here, come to my Lambda function and provide that security group ID. So I've got only one security group, so I'm good. And then said, tell me the subnet IDs. You can provide more than one subnet, but to be honest, one subnet is enough, because all it is going to do that is going to actually create an ENI in that subnet, so that Lambda function can use that ENI to connect to Redshift cluster. So I have this cluster is spread across 3 subnets. Just one subnet is ID is enough, because these subnets talk to each other. So one is enough. And then after that, what we do is that we acknowledge, since it's going to create a role, and this role will be assigned to the Lambda function. And basically this role actually gives permission to fetch credentials from the secret name, which is we are not using. I don't care, to be honest. I mean, I have to provide a name here, but basically it's not going to use that. And there's no secret with this name. So I can put any garbage here, still it will work. So let's deploy. So now the deployment will start. So it uses a CloudFormation template to deploy the applications. It's deploying a Lambda function behind the scene, and it is setting up the environment variables and runtime and everything, which is going to take some time. So if you see the Lambda function here, after some time you start seeing a Lambda function, and then you will also start seeing an application over here. So in the meantime, if I want to show you, let me open this CloudWatch. Let me open this up. Not exactly. Oops, what I'm trying to do. Yeah, okay, let me refresh first. Okay, you can see here that my connector is getting configured, and you will see my Lambda function is also getting configured. So we'll wait till our application is ready, and then and it's using infrastructure as a code behind the scene to deploy the whole infrastructure. So we will wait till this application is ready, and then I will walk you through first of all the configuration of the Lambda functions to show you some of the vitals configuration over there, so that you know what goes where. This information you put into template, what goes where, so you can play with it, you can modify that. And then I'm also going to then come back here and finish my remaining of the configuration and see if it works with my Redshift cluster. So just to refresh the status again, yeah, still creating for me. It takes a couple of minutes to create. So let's wait till my status changes to ready. Okay, so you can see that my connector application is create complete. It is ready, and as I mentioned earlier, that it uses CloudFormation to deploy the whole stack. So if you go to CloudFormation, you can see this CloudFormation stack over here. If you want to remove this configuration, whatever we did so far, like creating the application and Lambda function, you can simply delete this stack and it will remove everything. It will clean up everything. So my connector is ready. Now I can go to the function, Lambda function, and this is the Lambda function, Dojo Redshift connector it is going to use. If I click on that connector, few important information to know. So for instance, it is using Java run, it's a Jdbc connector. So it's using Java runtime 8. This is the name of the handler. So this is the name of the handler, the class which is actually taking care of the whole communication. Okay. Now, if I go to the configuration, few important thing to know. So for instance, if you go to the permissions, and if you look at, so this is the role which is created by my deployment and associated with this Lambda function. And actually look at this role permission. Actually it says it has get secret value permission from this secret, which right now is don't care because it's not working. But ideally when sometime this whole thing will work with the secret manager, then by this role, the Lambda function will have permission to fetch secret from this secret. Okay. So this one is giving it permission. Then we have got environment variables. So there are certain environment variables in place. You can see here it is providing the spill bucket and your spill encryption information, spill prefix, and those kind of things. And it is using a default connection, default as a connection string. And this is the connection string value. And this is again I don't like because my username and password is in open. Okay, and actually this is not sufficient. I'll show you later. I have to do one more thing, which is again not very well documented. Then if I go to my VPC, you can see in the VPC, my Lambda function is already associated with the VPC. So it has got into the same VPC where my Redshift cluster is. It is using the same, one of the subnets of the Redshift cluster. So it has a network path to the Redshift cluster and using one of the security groups of the by Redshift cluster. So by associating this Lambda function with the VPC, actually now Lambda function has a network connection to the Redshift cluster. So that was the walkthrough of some of the important configurations from the Lambda function point of view. Now let's go back to the Athena. So we refresh this button and see, okay, I can see my connection here. I will call it say Dojo RS catalog. Okay, so Dojo Redshift catalog. This is the name of the catalog I want to give, and then I simply connect, and then it has got connected to my Redshift cluster. So if I go to my query editor again, I can see this Dojo Redshift catalog, but it's not going to work. I'm expecting an error anytime now. Yeah, here we go. So I get an error where it says that you need to have, since you created a catalog with this name, Dojo Redshift catalog, you need to have a connection string with this name. Well, this has been documented, but it's not very clear. And I don't know, I mean, why they're using the default connection and those kind of things. But anyway, so what I have to do, you have to create a connection string with this name. So I just copy this name over here, and then I go back to my Lambda function. And I go to my environment variable, edit it. Then I say I want to add an environment variable, and my environment variable is this name. So this name I copy pasted from that error over here, and then value is same as what you see value here. Okay. And if I try to remove the default, it again throws error that there is no default connection. So somehow this part of documentation also I don't find very nice, but anyway, it works. So what you do here is that if you look at the error, it says that this connection, you must have an environment variable with this value, and you should have your connection string over there. So I simply copy that name over here, provided that connection string value here, name here, and then value over here, and then just want to make sure there is no space in the beginning or in the trail. Looks like no, and then we simply save it. So now my Lambda function configuration is over. So if you go back to my Athena, and let me close this window over here and refresh this data source again. Now it works. So you can see here, now it has connected to Redshift. It is showing me all 4 schemas. So if we try to compare here with the Redshift, for instance, here I have got 4 schemas. In fact, I have got more than 4, but it looks like fewer, like information schema seems to be private one. So what I see here is I see the schemas, and then I can click on the public schema, and I see the tables. You can see these are 2 tables which are under the public schema, and I can say, okay, I want to preview this table, and then I will see the data from the Redshift. Okay, anytime now. Yeah, here we go. Data from the Redshift. So you can see here that I have configured Athena with Redshift as the backend data source, and then it is using the federated query and data source configuration, the query data from the Redshift database. So that was all for for this video, guys. Hope you liked the video, and if you like, please click on the like button. Please subscribe to my channel, and I promise to come back with more such videos and tutorials in the coming days. If you have any feedback or comments, or you want to correct me, I did something wrong, or you have any questions, any request for new content, then you can provide those feedback and comments into the YouTube channel comment section. I always look forward to your feedback to improve the content, improve the presentation. I promise to come back again in a couple of days' time with another such tutorials or the videos. In the meantime, stay safe and have a nice day. Bye-bye.